Hello everyone, my name is Mr. Amoyavi and I am one of your grade 12 advanced maths teachers. In our last lesson we talked about differentiation from the first principles method. In today's lesson we'll be talking about the rules for differentiations. Rules for differentiation. Right, what is the rule for differentiation, or what is actually a differentiation? Differentiation in calculus is simply the process or method that is used to find the derived function or the derivative of a function. Right, so generally, if I have a function y is equal to f of x, then the derivative of this function will be denoted or represented by this symbol dy over dx, or it can be represented as f prime of x. All right, so the rule for differentiation is this. If I have a function y is equal to ax raised to the power of n, it is a function, a polynomial function or an algebraic function, then the derivative of this function will be like this. What you need to do is you have to bring the exponent n in front and multiply by the coefficient a. So it will be a times n will be just simply an x raised to the power of. The next thing that you need to do to this function is to minus 1 from the exponent n. Right? So this is basically the rule for differentiation. You bring the n in front, multiply by the coefficient, whatever coefficient it is, and then you subtract 1 from the exponent. Right, that's number one. Number two is if I have a function that is equal to a constant number, then we know this function is basically same as y is equal to c multiplied by x raised to the power of 0. You know, x raised to the power of 0 in indices in grade 11 is equal to 1. So 1 multiplied by c is simply this. Right? So we can take this and find the derivative for this function using this rule. So dy over dx of this function, if I have to bring the 0 in front, like I bring the n in front, it will become 0 multiplied by c x raised to the power of 0 take away 1 is going to be negative 1. Right? So we see that 0 times all of this number, it's simply multiplication, so we will end up with 0. So this result here tells us that the derivative or the gradient of a constant number is always 0. So these are two important results that we are going to use to find the derivative of any given polynomial function. So now we look at a few examples. A. For example, if I have y is equal to the function 3x squared minus, let's say, 4x. All right. What would be the gradient of this function? Okay, simply don't forget this. We're just going to apply, write our dy over dx, and on the right side expression we apply this rule where we bring the 2 in front, multiply by 3, it gives us 6 x, and then we are going to subtract 1 from 2 and it becomes 1. So normally that power of 1 is not written. And then we apply the same rule to this term here. You know, there is power 1 there. So 1 brought in front, 1 multiplied by negative 4 is negative 4, right? 1 take a 1 will be 0, and x raised to the power of 0 is just simply 1. So 1 times negative 4 is this. So this is the gradient function of this function. Okay, let's look at example B. If I have, for example, a square root of x, right? we have to rewrite this using the previous knowledge in grade 11. We can rewrite this expression as y is equal to x raised to power of half. Okay, square root of half, x rather, is same as x raised to power of half. Once I do this, I can now apply this rule for differentiation. Therefore, dy over dx is equal to, I bring the exponent in front, which is half, multiplied by 1 is just half, x raised to power of, what am I going to do? I will have to subtract 1 from this. So half take our 1 will be a negative a half, right? So this can be basically written as 1 over 2 multiplied by, this is a negative exponent, so this can be also brought down and say 1 over square root of x. And so it becomes 1 times 1 is 1 over 2 square root of x. So this is basically the gradient of this function here. Now let's take a look at the last example, C. Okay, if I ask you to, if you are given this function and you are asked to find a gradient, let's say, given this function, y is equal to, let's say, 2x cubed, find the gradient at x equals, let's say, 2. If I'm given this question, then I will just have to simply work out the gradient of this function. The gradient function of this will be dy over dx is equal to, bring the 3 in front, 3 multiplied by 2 will be 6, and then we just have to minus 1 from this, so it will be 6x squared. This is the gradient function. So what will be the gradient of this line at this point? It will be basically, therefore, the gradient at x equals 2 will be simply dy over dx at x equals 2, we just have to simply substitute here 6, 2 multiply 2 raised to power of 2. Evaluating this, 2 squared is 4, 4 times 6 is 24. All right, so this number here indicates to us that it is the gradient of this function here at x equals 2. Right, so in this lesson, what we have learned is the rule for differentiation. And that is to find the gradient function or the derivative or the differential coefficient. So the rule is basically this. To recap, we just bring the exponent in front and subtract 1 from the exponent. And that is the rule for differentiation. Right, so given any polynomial function, you just have to apply this. And the second one, don't forget, if you are given a constant, the gradient is always 0. Right. So this brings us to the end of the lesson. And in our next lesson, we are going to discuss tangents and normals. Thank you, everyone.